welcome to this presentation of this video. So I want to uh, showcase to you this project, machine learning project. As you can see on my background, we have my the, the 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 VS Code that contains the Jupyter notebook. So it's an advanced regression machine learning using advanced regression techniques. So before I delve into the project one by one, I want to show the data set that we have. So right away, that's our data set. You can see it is quite a huge data set that contains a bunch of columns here. There are quite a lot of columns. So from this data set, we're going to do an advanced regression machine learning method. So we are going to try to predict, specifically this dataset is called Hermes housing dataset from the Kaggle datasets in Kaggle. So you can see it's very, very huge dataset here. It requires a lot of feature engineering and feature extraction in order to achieve a wonderful machine learning algorithm. So right away, let me just transition to yes, as I said, it's advanced machine learning techniques and libraries for machine learning libraries. We're going to use a bunch of the machine learning algorithms like linear regression. We're going to use decision trees. We're going to use random forest and ridge regression among others. We're going to also use hyperparameter tuning using randomized CV, randomized search CV. So right away, I load my dataset into the training, to the memory, and just a quick look, you find out that there's 1,460 rows and 81 columns. The entire dataset has 81 columns. That is quite huge. That's quite a huge number. 81 columns here with us. Just as you can see, we have 81 columns here. Then another quick info about the dataset. We find that we have, out of the 81 columns, most of the 81 columns have no null values, except we have here array, which has significantly a lot of null values. So we're going to see what to do with it. We also have at least one of the columns here with some few missing values. This load frontage here. Yeah, so it has some few missing values enabled. We're also going to see what to do with it. So then here I do a description to see statistical view of the numerical columns of this data. Then this is the output. We get 8 rows out of 8 columns to find some wonderful statistical view of the data. Then another thing I do, I plot a histogram to give me a quick and faster intuition about the data and how the numerous column. For example, this is categorical. You can also see here overall overall condition, categorical, and this overall quality, it's categorical, and it's also a normal distribution. See, normal distribution. So that is how a quick histogram plot of the dataset provides some wonderful, wonderful insights. The next I want to visualize the data dataset so that I may see the behavior of this. So target variable analysis, sales price. So I want to do the sales price analysis. This is our target variable. We are going to predict the sales price of different houses. So we are going to do machine learning where we first of all train the algorithm on some labeled data. After that, we're going to perform a test on some unseen data so that we can try to predict what could be the prices, house prices, given this wonderful features here. So the target total bathroom. Then I also asked, I did has a garage or no. This is a Boolean data type that I engineered, and you see the result here is amazing. We have an increase in the correlation. This new features has great correlation to the sales price. And you see this is 0.77, but now total SF it becomes 0.7777. You see that's a great increase. Then garage area, total basement, full bath, first floor, second floor. So when I join them together, you see it becomes a highly correlated good predictor of the sales price. That is interesting. Now another thing I do is the agent time features. I feature engineer exact age of the house and the times of the house because we are just giving the year built. So we want to find the age of the house given the year built. So we minus the current year, which is 2025, to find the age of the house. So that's the age of the house is also highly correlated. You see 0.55. The original was 0.58. So we also have here since the model 0.56 is new 0.4. At least in a good way, a kind of predictor. I do feature encoding for the categorical data so that at least machine learning can have a meaning from them. Then you can understand, the algorithms can understand. Remember, machine learning algorithms, they don't understand text. They have to understand. You just have to input, extract and replace missing values here, and then extract efficient quality. See now this is now for the aggregating. Okay, yeah, I aggregated like qualities to make one full quality of the house, like quality of the kitchen, quality of the basement. So then I want to bring them together to make one whole big feature that represents the overall quality of the house. And then we find that after making it, that featured engineering to make a one quality, you see, it has 0.8000. So this is the most highly predictor feature that we have engineered. You see, it's very, very high. 0.8, that's serious, very big. 80%. It's a good one. Then now, next thing I do is to combine the features together so that I can use it to train the model. So, and then I split the data now, X and Y. Then I choose the most promising features that we've engineered, as well as the other features, and then the other features that we've not seen that were there in the data, we also fill them with with the missing values, fill the missing values with the median, and then now we do the model training after splitting the data to training and test set. Then now we split the data here, training and test set, X and Y, and then I will do called a CV, that is cross validation, negative mean squared error, and then each and every training, you see it's still very low, some 0.19, 0.2. This tree is just performing so poorly in this data. So then I say, okay, now let me try random forest, which is an ensemble of decision trees, to see how it will perform. And it turns out that the random forest algorithm, regression algorithm, did so well with this data until I was impressed. I was impressed so much, and I said, this is wonderful now. So look at how the random forest has just done it. It is able to produce a root mean squared error of 0.1446. That's quite low compared to the others. And the root mean squared, that translates to roughly 28,500. So this has minimized really the cost function. I like it. It really impressed me. So the next thing I do is hyperparameter tuning for the random forest model, because the best performing model. So I want to do a hyperparameter tuning to at least try to improve its performance. So after doing a randomized search CV, then we find the result to be also striking. You see, it reduces furthermore to 0.1442 from 0.1446 to now 0.1442. It works very well. So that is really impressive. Very impressive. So I can tell right away, yes, we are just take the random forest regressor as your final model. So that is very wonderful. I wanted also to compute feature importance to understand which are these features that contributes to this performance in the random forest algorithm. And it turns out that most features that are highly important for the predictors is the overall quality interaction. Then we have total. So actually, you can see these are the features that I engineered. So you see, feature engineering is very important. That's why this project is called Advanced Regression Techniques. So it's advanced because you need to feature engineer some of the features from the overall given features. The given features sometimes some are not good predictors, but if you bring them together, the algorithm will be a good predictor of the sales price. We go to, so these are the feature importance, top 10 features ranked as the importance of the random forest tuned random. Yes, these ones here. These are the top 10 features that are ranked there. And you see they're very, very important here. Important 0.25, 0.19, so all through there. The next thing I do is I train the random forest now on the whole training, all the training data set that we are using. Remember, I splitted it to allow for cross validation, but now I want to just train it totally on it, that is X and Y. You see, and it performs very well. And I saved it. After saving it, then I'll use it as a predictor now for the given given test set. For example, let me just show it here. It is here. So the given test set CV, this I'll use it to test it here. Then I'll also produce an output in a submission.csv. You can see I just come to it. But so after having that random forest random forest regressor model, then I just, so you see this is the performance. So this is in a nutshell is the advanced regression algorithm that I performed, and it has been one of its kind, though it was kind of I can say it was kind of tricky, and a lot more demanding to try to figure out which features are the best. It takes time, but finally, I found a way to engineer the features, and it worked significantly better, even though it's not better, but at least it tried to bring some good performance. That is it. Thank you so much for staying with me. See you next time.